Right. In ABGP, we saw the configuration of EBGP and IBGP. In BGP, we have two flavors. And in EBGP, what we saw is the neighbor need to be directly connected. It means a lot, actually. I'll explain you later what it means in real meaning. Directly connected is, directly connected is one meaning. It's not that simply directly connected. Uh, so, yeah, so now, this is the, we have come up to here with a lab, isn't it? IBGP, EBGP. Now, this is something important to understand whenever we use BGP. See, there is one autonomous system in the middle, which is running BGP only on router B and router E. And there is no physical wire connecting B and E. The dotted line represents the IBGP peering. You remember we learned that we can form neighbor with the remote router in IBGP if reachability is there. Yeah, if route is there. See, we have OSPF running on this 4 router, B, C, D, and E. As a result, reachability will be there definitely, isn't it? So using the reachability, IBGP is negotiated, and also the directly connected A and B are EBGP. E and F is also an EBGP neighbors. Fine. Now, let's say F is advertising a network like this. You see, same scenario, same picture, right? Do you have BGP on D and C? And you see there is a network advertised by F. Sorry, there is a network advertised by A. A is advertising this network. And now F has learned it in the routing table. Now, from whom F learned this 10 network? Of course, it is E. So will there be root in the, will there be any root in E routing table? Yes, there will be route. What will E have as a gateway to reach 10.0.0.0? Hmm. Hmm. Yeah. So E will say you need to go to B to reach 10.0.0.0. Fine. To reach B, will there be any root in the routing table? E. Okay. See, what you said is correct. 10 network should go to B, isn't it? In routers E routing table, it will say you need to go to B. And how to go to B will be provided by OSPF, isn't it? And OSPF will say you should go via D and C, isn't it? Yeah. So now the packet with the destination address 10.0.0.0 goes to D. But will there be any route to reach 10 network in D and C? No. Why? Because we are not running BGP there. Because you are not running BGP, the BGP updates will not be learned. It will simply pass the update. See, when A was giving update to B, D was simply taking and passing it to E. Yeah, BGP update. Yeah, IBGP update. Because it is not delivered to D, D cannot learn it. Even though D is passing the update, D will not synchronize with the update. Why? The to address is E, not D, isn't it? B is sending update to which address? Its neighbor's address, E. That is the delivery address. So E will simply forward the update. That is how E learnt about this 10 network. That, and then, let me finish. 1 minute, sir. Let me finish. 1 minute. And this 10 network is given by EBGP to F. Now, when F forwarded the packet to E, E will forward the packet with the destination address 10.0.0.0, but D do not know. D did not learn, so it will drop. Okay, now you ask me a question. Hmm. See, A is another autonomous system. We will not be running OSPF on A and F. We will only rely on the security protocol, which is BGP. So the routes given by BGP will be only given to BGP running routers. The other routers may be in the path. They will simply forward it. Without synchronizing, they will simply forward it. Clear, no, sir? As a result, the routing table of DNC will not have routes to telnet word. So now, what is the solution? We are going to learn. All right, what is the solution? How can we solve the problem? We will learn it. Now, sometime some people will see redistribution as a solution. See, through BGP you are learning. From BGP, if you redistribute to OSPF, it will go to all the routers. And here from OSPF, you can take it and redistribute to BGP, and it will go here. But this is not a recommended solution. Why? Why this is not recommended solution? Why this is not recommended solution? It is because when you redistribute from BGP to OSPF, what is BGP bringing? External network, isn't it? When you redistribute to OSPF, your internal networks and the external networks will get mixed. And again, if you take the OSPF route and redistribute to BGP, not only the external network of A, even the inside network of B, C, D, E also will go here, which is not safe. See, this is ISP. If this customer A wants to reach the customer F, A needs to know F, F needs to know A. Why should the inside network of ISP revealed to A and A? Why should those networks be exposed? So redistribution is not recommended solution. Is it clear, sir? What is recommended is better you run IBGP on all router in this scenario. Okay, so run here also BGP, also here BGP, so that when A gives the update, B will also give to D, isn't it? Like B is giving to E, it will also give to D. Okay, so we have understood that why I should run BGP on all router. When I say this one, when I say that BGP need to be enabled on all routers, when I say this, what people do, they will immediately get one question in their mind. Okay, anyway, you are going to run BGP on all router. Why are we running OSPF? That's actually a question commonly comes to everyone because we are not thinking deep. You see, I already told you, BGP we want to use for external network only. So for internal, we want an IGP protocol. When you remove OSPF, then you have to run BGP for your internal network also. Then there will be a problem when you give the routes to F. All your internal network also will go, isn't it? Hmm. So let the IGP protocol OSPF take care of internal network and BGP protocol take care of external network. So the updates of A is carried to B, C, D, and E by BGP, not by OSPF. OSPF is just providing reachability between B, C, D, and E networks only. Is this things clear? Now, now the story is not over yet. We have another problem. We have decided to run BGP on all router. That is true. But you need to run in a full mesh fashion. You need to run full mesh. What is full mesh? See, here also you're running BGP, no? All router. Here also you're running BGP on all router. Then what is the meaning of partial mesh and full mesh here? The meaning is this. Here, B is neighbor with the D. You see the dotted line. D is neighbor with E. B is neighbor with C and C is neighbor with E. But it is not forming neighbor with E. You see? D is also not forming neighbor with C. So, yeah. So forming neighbor is the matter. It's not a physical cable. This is not cable. We are not expecting a cable. In B, you should say E as a neighbor. Not just D, you also need to say E. So in B, you have to say neighbor as D, E, and C. In C, you have to say neighbor as B, D, and E. In E, you have to say neighbor as B, D, and C. Likewise, in D, you have to say neighbor as B, C, and D. Whereas here, you have only neighbor with D and C, not with E. Here you have only neighbor with C and D, not with B. Now, why is it so important? What is the problem with partial mesh? You may say partial mesh is enough. Why you are saying that? Because you are saying this guy will give to this guy, this BGP will give to this BGP, and this BGP will give to this BGP. and this will give to this. So you are correct. But that is not the way it works. Why? In BGP, to prevent loop in an IBGP environment, what is this environment called as? Is it EBGP or IBGP environment? IBGP. In order to prevent loop in an IBGP environment, there is a rule. What is the rule? Route learned via IBGP or never propagated. You see, it's negative. Never propagated to other IBGP peers. What does that mean? When D learns the update from A, the 10 network, when D learns the update from B, is D learning from IBGP or EBGP? Hello, please focus. D is learning from whom? Delhi is receiving from Bengaluru. Is it having an IBGP relationship or EBGP relationship with Bengaluru? Then why did you say EBGP? Okay, sorry then. Okay, Delhi is learning. See, you see here, the route learned from Bengaluru. Delhi will never propagate to Ernakulam. It will not propagate to Ernakulam. That is to prevent loop in IBGP environment. So, when you form full mesh, this guy will give to this guy. B will also deliver to this guy directly. Even the packet is going via D, it is delivered to whom? E only. It's a TCP based, no. And B will deliver to C. Now E, whatever it learned from B, it will give to F. You understood now this? Why it need to be fully meshed? Because the route learned via IBGP are never propagated to other IBGP peer. So they need full mesh IBGP. So in this chapter, what we learned is the difference between EBGP, IBGP, and also this very important thing. You know, when there is an autonomous system designed like this in a transit, we need to make full mesh, otherwise there is a problem. We discussed these problems and the solution. Yeah. Now let's move on to the next chapter. Configuring basic BGP operations. Next a few pages, you know it very well. So what I'll do is I'll stop you like this for 2 minutes. You give reading, and if you have any question, please ask me now. So if no question, we'll move on to next page. This also I want you to read. Look at this example. Is it over? So we learn how to temporarily shut down a neighbor, bring it up. Now, this is another serious topic, important topic we are entering in. This page and another 3 pages. They're all connected. I'll stop for a while and you give one quick reading, then I'll explain this. To understand this page, the next page picture is also important, but without understanding this at least half, going to next page is useless. So let me take you one step back. See this picture. What is the neighbor address in router B? In router B, what is the neighbor address? Okay. So when router B send the packet, it will say source as 10222 and destination address as now this packet will go whom? Will go to A. Correct. Now A will check the source of the coming packet. Is that source mentioned anywhere in the neighbor statement? Yes. Only if it is, yes, you see, only if match is found, the relationship will be established. If match is not found, the packet will be ignored. So make sure the source of the packet, BGP update, BGP packets, matches with the address in the other router's neighbor statement. You understood this now? Now I want you to go back again. Try understanding this one more time. You understood very well? Now you read the first paragraph also. You understood now? Okay. Why are they saying this to us? For that, you need to go to the next page. Now, I'll give you another 1 minute. Go through this and answer the question below. Why are you saying the loopback address will be used to make neighbor? Why are you saying this as the answer? On router A, to form neighbor with D, I can form neighbor with this address of D, this address of D, this address of D. Why are you saying this is the address that we should use? Why not this? Why not this? So you will have route to 4444. I don't know. I can understand a little bit that you know the answer, but sometimes you are not completing the answer. So I get doubt. Can you explain me what you understood? Why are you recommending to use loopback? How that can happen? Okay, I'll try to answer what you are trying to tell. Okay, I'll try to tell what you are trying. You see, A to D, you got two paths. What you're trying to say is, if I form neighbor with loopback, even if one of the path goes down, maybe this link going down, or this router going down, or this link going down, even if that one path goes down, you will still have reachability to this address via the other path. So instead of saying the loopback address, if I would have said this address, then when the path goes down or the link goes down, I lose my neighbor. If I form neighbor with loopback, if any one of the path is available, I'll have reachability, so the neighbor will still continue, isn't it? This is what you are trying to say, correct? Okay, nice. That's a good answer. Now, according to what you said, on router A, the neighbor address will be, please tell, neighbor address will be, now A is trying to send a packet to D, BGP packet. Tell me, what will be the destination address of the packet? A is sending BGP. Hmm, hmm. Now, what will be the source address? No. Listen. Then you forgot this point. Read this point. Okay, now tell me, what will be the source? Hmm. Let's assume 10.1.1.1. Okay, now this packet, now it will go to D. What will D check? What will D will check the? If match found established, is there a match? What is the neighbor according to D? Is the source matching with the neighbor? If no match, so what do you need to do? Correct. So I have to somehow make the source address to avoid this address and use this address. Agree? Only then the match will be found, isn't it? How to achieve this? We saw in the previous slide, usually it takes the source address as the outbound interface address. But if that is the case, then I'll not form neighbor, because the second point, the match is not found. The packet is ignored. So I have to somehow do something to tell BGP not to use, but to use loopback 0. Not to use the outbound interface, not to use the outbound interface, but to use the loopback interface address. How can we say, how can we say this? This is how you say this. Read these lines. I'll give you 2 minutes. Read these lines. Correct. When I say neighbor 4.4.4.4, update source, loopback 0. When I say that, what happens on router 1, when I say this, when I say neighbor, when I go to router A and when I go to router A and say neighbor 4.4.4.4, update source, use the loopback 0. What is in loopback 0? So I'm asking BGP to send all the updates sourcing from loopback 0. You understood now? Now, you see. Yeah. In eBGP, it needs to be directly connected. If you say loopback, are they directly connected? They are not directly connected. Okay, now, see this example. Explain me after you understand. Hmm. So the address is getting changed, no? To loopback 22222. All right. For eBGP, we have to do something else to accommodate this, which we'll see in the next class. Right? We will do a lab on this update source in IBGP first, and then we will see this eBGP challenges. And then in eBGP, if I want to use loopback to loopback, the challenges and the solution, something like this, eBGP multi-hop 2, those things we'll see, and then we will do this lab. Okay. First, we need to do this lab.